Watching a new airliner roll out of the factory is awe-inspiring, but the real magic happens behind the scenes. Boeing and Airbus, the titans of commercial aviation, each have unique approaches to building aircraft. Both rely on assembling large components from around the world, but their methods differ in key ways. These differences affect everything from production speed to aircraft design. By comparing models like the Boeing 737 and Airbus A320, we see how each company's strategy shapes their planes. Today's assembly lines are streamlined, modular, and global, with major sections arriving as prefabricated modules. The real divergence is in how these modules are designed and joined, a process that's constantly evolving. Let's dive into how these philosophies create the airliners we trust every day. The biggest difference starts with the fuselage. Boeing traditionally builds fuselages from large aluminum panels attached to a frame, allowing easy access for early systems installation. Airbus prefers assembling entire cylindrical sections, barrels, before joining them, streamlining outfitting and boosting precision. Boeing's 787 Dreamliner broke tradition with one-piece composite barrels, reducing fasteners and weight, but requiring massive new equipment. Airbus's A350 uses large composite panels, a hybrid approach that balances logistics and structural benefits. Both methods aim for lighter, stronger, and more efficient aircraft, but each comes with unique manufacturing challenges. These choices reflect each company's philosophy and drive innovation in aircraft design. The result? Two distinct paths to building the world's most advanced airliners. Once fuselage sections are joined, the next milestone is attaching the wings, a feat of precision engineering. For narrow bodies, wings are built as a single center section and joined to the fuselage. For wide bodies, left and right wings are attached individually. Laser-guided tools ensure perfect alignment, as even tiny errors can affect performance. Meanwhile, complex systems, wiring, hydraulics, avionics, are increasingly pre-installed in modules before final assembly. This pre-integration speeds up production and reduces cramped post-assembly work. Wiring harnesses and floor panels often arrive pre-equipped, transforming the assembly line into an integration hub. These advances allow multiple teams to work in parallel, boosting efficiency. The result: faster, more reliable aircraft production. Every step is a blend of engineering precision and logistical mastery. Final assembly brings everything together: fuselage, wings, tail, and landing gear. Older methods use stationary docks, but now, moving assembly lines inspired by the auto industry dominate. Aircraft move steadily along the line, with teams working in sync to keep production flowing. Both Boeing and Airbus use this system for high-volume models like the 737 and A320. Shared suppliers mean innovations often benefit both manufacturers, driving industry-wide progress. Boeing's one-piece composite barrels and Airbus's modular sections highlight their different strategies. These choices impact cost, speed, and aircraft performance. Understanding these processes reveals the remarkable effort behind every flight.